So good morning students, welcome back. Today we'll discuss force on charged particle in magnetic field. Whenever the charged particle travel in magnetic field, when move in magnetic field, it experience force, magnetic force, that we'll find today. Okay, so let's start. Force on moving charge in magnetic field, that will be our topic today. Okay, look students, first of all we'll assume a charged particle Q. Look at students, that is a charged particle Q that is moving with velocity v in magnetic field B. This is the magnetic field. Cross means magnetic field perpendicular downwards, inwards. Okay. Now students, charged particle is moving with velocity v in magnetic field B. The velocity of charged particle having two components. Horizontal component taken as v cos theta and vertical component is taken as v sin theta. Okay students, and this charged particle is making angle theta with x axis, okay, and moving with velocity v. Generally what happens students, whenever the charged particle travel in magnetic field, this magnetic field will exert force on charged particle. This magnetic field will exert force on charged particle. Okay, it is given by Lorentz, that Lorentz is the name of scientist. This force depends on three factors. This force experienced by magnetic field, whenever a charged particle travel in magnetic field, okay, with certain velocity v, this magnetic field exert force on charged particle. This force is directly proportional to the magnitude of the charged particle. Force is directly proportional to the magnitude of the charged particle. For small charge, force will be less, and for more charge, force will be more. On increasing one factor, other factor will also increase. On decreasing one factor, other factor will also decrease. Secondly, Lorentz found force is directly proportional to the vertical component of velocity, F proportional v sin theta. He got all these by his experiment, by observation. Okay students, force is directly proportional to the magnitude of charge, force is directly proportional to the velocity, vertical component of velocity. Okay, and finally he found force is directly proportional to the magnitude of the magnetic field, intensity of the magnetic field. For strong magnetic field, it exerts more force. For weak magnetic field, it exerts less force. Okay students, when we combine all that three, we can write from equation first, second and third, we can write F proportional Q V B sin theta. What we need? We combined all, F proportional Q V B sin theta. Students, whenever we remove proportional sign, we always use equal and constant. Here I am using constant K. Okay, Q V B sin theta. Look at students, for unit magnetic field. For unit magnetic field, constant K is taken as unit. Constant K is taken as unit. Okay, so we'll get the form F equals to Q V B sin theta. This is the simple form, and what will be its vector form? F equals to Q vector V cross vector B. Equation 4th, and that will be equation 5th, and this is the final form. F equals to Q V B sin theta, either F equals to Q V cross B. Students, we know whenever we remove sign, they will always come cross. Velocity is vector, magnetic field is vector. When we remove sign, there comes cross. Okay, so you get F equals to Q V cross B, either F equals to Q V B sin theta. This is the force experienced by a charged particle when it travel in magnetic field. This is also said to be Lorentz force. Actually, Lorentz force is a combined force experienced by a charged particle where electric and magnetic field both exist. So actually, what is the main form of the Lorentz force? I'm going to tell you. You can take a screenshot. Okay. Now students, I'm going to remove this portion. Actually, I want to introduce you with Lorentz force. Force experienced, total force experienced by charged particle in the presence of electric field and in the presence of magnetic field. Okay, because moving charged particle having both the fields, electric field as well as magnetic field. So what is Lorentz force? It is a combined force exerted by electric or magnetic field on a charged particle. Okay, and we know very well what is the value of electrostatic force. F equals to QE, where E is electric field. And what is the magnetic force that we found today? Q V cross B. Okay, students. So we can take common as Q. So we'll get vector E plus vector V cross vector B. This is the form of Lorentz force. So we found first of all force on charged particle in magnetic field, and this is said to be Lorentz force. Okay, students.